University. And yes, I'm back for another video, and for today's vlog, we'll be discussing about arcs, central angles, and inscribed angles. So let's get started. Hello again everyone. So for this lesson we have arcs, central angles, and inscribed angles. So you are tasked to derive the relation among chords, arcs, central angles, and inscribed angles, and also state and prove the theorems relating to chords, arcs, central angles, and inscribed angles. So we have here a figure. As you can see, can you guess which of it is the central angle and the minor arc, and also with the major arc? And give the intercepted arc of our angle AOB and our angle BOC. So let's dig into our topic. First, we have to identify arcs and central angles. So an arc of our circle is a part of a circle included between any of two of its points. So as you can see in the figure, we have 2 points. Our 3 points, we have point A and point B. That makes our minor arc. And it is classified into 3 categories. We have minor arc and our major arc, and lastly our semicircle. If 2 points on a circle divide the circle into 2 arcs and the arcs are unequal, then the smaller arc is the minor arc and the larger arc is the major arc. If 2 points divide a circle into 2 equal arcs, then the equal arcs are semicircle. As you can see here in the figure, it formed a semicircle. So we have here our 2 points that divides our circle, which is our point D and our point E. Next, we have here central angle. A central angle is an angle whose vertex is the center of the circle and whose sides are radii of the circle. As you can see here, we have our radii here, AP and PB. So the degree measure of the intercepted arc is equal to the measure of the corresponding central angle. So we have here our P is our central angle. For example, we have our central angle given by 25 degree. Then our minor arc would also be 25 degree. So note that the measure of a minor arc is less than 180 degree. And our major arc is greater than 180 degree. And of course, the measure of a semicircle is equal to 180 degree. Note also that the whole revolution of our circle is equal to 365 degree. So for this topic, you will learn about postulates and theorems. So for postulate 1, we have here arc addition postulate. It means that the measure of an arc formed by 2 adjacent non-overlapping arcs is the sum of the measure of those 2 arcs. So if we have here our 2 arcs AB, as you can see, we have here our arc AB and arc BC. So for example, we have to put this a given. So we have a given measurement. Our arc AB, we have 65 degree and our BC is 75 degree. Then we just have to add. So we have here our measure of arc AB plus the measure of our arc BC. So we have 65 degree plus 75 degree, then equal to 140 degree. So that's the main purpose of our postulate 1, which is arc addition postulate. So next we have here theorems. So for theorem 7, in the same circle or incongruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. So look at this figure here. As you can see in my cursor, if we have here angle BAE and angle CAD, so we have here angle BAE is congruent to our angle CAD because they have the same central angle. So if they are congruent, if our angles are congruent, then our arcs on both sides are congruent. So we have here our arc BE is also congruent to our arc CD. Now for theorem 8, we have in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are also congruent. So if you have seen here, we have arc EB. So as you can see, we have here our arc EB and our arc CD. So if both sides of our arcs are congruent, then our chords would also be congruent. So as you can see, we have our arc EB here is congruent to our arc CD. Then our chord EB, as you can see, our chord EB is also equal to our chord CD. Next, we have here Theorem 9. So for Theorem 9, in the same circle or in congruent circles, two chords are equidistant from the center if and only if they are congruent. Okay? We have here our line OE and our line OF is equal because as you can see, our OE here is perpendicular to our AB, which touches the point of our line. Okay? And of the same also with our line OF is also perpendicular to our line CD. So therefore our chord AB here, our chord AB is congruent to our chord CD if our line OE and OF are also congruent. Next, we have here our theorem 10. In the same circle or in congruent circles, if two chords of a circle are unequal in length, then the longer the chord is nearer to the center. So as you can see here, our chord AB is longer or greater than our chord CD. Therefore, our chord AB, which is our longer chord, is nearer to our center, which is our center O. Okay? Next, we have here inscribed angles. So inscribed angles is an angle whose vertex is a point on the circle and whose sides are the chords of the circle. As you can see in the first figure, we have here an angle A and its vertex is on the circumference of our circle. Then it formed an inscribed angle. So we have here our angle. A intercepts minor arc BC. So it intercepts our arc BC. So next figure, we have here our angle A intercepts a semicircle, which is CDB. As you can see here, it's a semicircle. And our semicircle is equal to 180 degrees. Okay? And it can intercept a minor arc, a semicircle, or a major arc. Now for our third figure here, we have angle A intercepts major arc CDB. As you can see, it's greater than our semicircle. Okay? So it's greater than 180 degree. Next, we have here Theorem 11, Inscribed Angle Theorem. So the measure of an inscribed angle is 1/2 the measure of its intercepted arc. For example, we have here our intercepted arc is 120 degree. Then our central angle is 60 degree. And for example, we have here a 20 degree. Then our intercepted arc would also be 40 degree because it's 1/2 of our intercepted arc. Okay? Next, we have here corollary 1. So a corollary 1, an angle inscribed in a semicircle and intercepts a semicircle is a right angle. So we have here circle O and our angle CAB is an inscribed semicircle which formed a right angle. Next, we have here corollary 2. inscribed angles that intercept the same arc are congruent. So in given circle O, we have angle D, which intercept our minor arc BC. The same also with our angle A, which also intercept the same arc. Okay? As you can see here, our angle A and our angle D intercept the same arc, which is our arc BC. Next, we have here corollary 3. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So we have here an circle O, A, B, C, and D inscribed form a quadrilateral. So what is a quadrilateral means? I mean a supplementary. The two angles are called supplementary when their measures can add up to 180 degrees. So given here in our circle O, we have ABC as an inscribed quadrilateral. So for example, if our angle B and its opposite angle is angle D, as you can see, our angle B, its opposite is angle D. And the same also with angles A and C are opposite. For example, we have here our angle B is equal to 125 degree. Then our angle D would equal to 55 degree. The same is true with our angle A. For example, we have 87 degree. Then our angle C would equal to 93 degree. Next, we have here for corollary 4. If two arcs of a circle are included between parallel chords, then the arcs are congruent. So if our chord here, our chord AB and CD are parallel, then their arc is also congruent. Okay, at this point, let's have an example. So given here, this figure, so if we have in circle O at the figure to the right, our DO is equal to our AB. And the measure of our arc DB is equal to 120. So our arc DB here is equal to 120. Okay? Our arc DB. So as you can see, we have our arc DB here, which is equal to 120. So remember that it's equal to 120. Okay, 120. Then find the measure of our arc AB. Since we have our line AO, BO, and CO, and DO are the lengths of our radii. So we have AO is equal to BO, equal to DO, and equal to CO. Because our DO here is equal to our AB, it follows also that our AO is equal to AB. Okay? Our AO is equal to AB. By this, we form an equilateral triangle. As you can see, it formed an equilateral triangle, and we know that the angle is an equilateral triangle is 60 degree. So we have here 60 degree. And since by our measure of arc AB is 60 degree, because our central angle is equal to, since our AB is the intercepted arc of the central angle AOB. So we have here our arc AB is equal to 60 degree. So we have here our AB is equal to 60 degree. Next, we have to find the measure of our arc AD. Okay, our arc AD. Because the measure of our arc DB is 120, arc DB is 120, and the measure of our arc AB is 60, then the measure of our arc DB will be equal to measure of our arc AD plus measure of our arc AB. Okay? We have here um, DB, measure of our arc DB equal to, then this will be our formula, measure of our arc AD plus measure of our arc AB. So as we know that our DB is 120 equal to our AD is our unknown AD plus the measure of our arc AB, which is 60. So here our AB is 60 and our DB, arc DB is 120. Then we have to find our AD. Then we have here our AB equals to 60. Then we'll have AD let's equate 120 minus, then we have negative 120 plus 60, then we have our measure of our arc AD is equal to 120 minus 60, we have 60 degree. Okay, so the measure of our arc AD is 60 degree. Next, find the measure of our arc DBC. Okay, let's find our measure of our arc DBC. So here DBC. So in finding our arc the measure of DBC, since the measure of arc DBC, as you can see here, the measure of our arc DBC is 180 degrees. Since the whole circle is equal to 360, then as you can see, our DBC is equal to a half of our circle. Then the measure of our arc DBC is equal to 180 degree. Next, we have here, find the measure of arc BCD. Okay, so let's have BCD. BCD. Okay. So let's have to find our arc BCD. Measure of our arc BCD is our unknown plus measure of our arc DAB since our DAB is 120, and we have to find our DAB is 120. Then as you can see, if we have to find arc DCB, and we know that our whole circle is 360, then we have to minus 360 equal to 360. These two arcs will equal to 360 as you can see in the figure. Then we'll have 360 measure of our arc BCD equal to 360 minus measure of our arc DAB, which is 120. Then 360 minus 120, we have 240. So the measure of our arc BCD is equal to 240 degree. So that's all for today, guys. Thank you for listening, and I hope you learned a lot from this video. Thank you for watching. Bye.